So hello DrupalCon. My name is Alexey Karepov. I work for EPAM, and today I want to talk about end-to-end observability, and especially with decoupled Drupal and microservices that we usually use. And I can say that it's possible now, and I'll show you how. And observability, yeah, that's a good question. So what is that observability? Observability is the ability to measure the internal states of a system by examining only its outputs. So in our case, Drupal outputs. And let's remember what outputs our Drupal can provide. Out of the box, actually not a lot. The white screen and our watchdog output, right? And that's it. Probably that's enough, right? But observability relies on three output pillars. The logs, you know logs, that files with boring text lines. And metrics that colorful charts that can look great. And traces. Oh, traces. What is it, traces? You know logs, right? These lines with message type, date, and other fields. And traces are like logs, but better. They can represent all actions that happen under the hood after the user action on the front end through all the gateways, services, microservices, and even database. And they can be represented as visually as colorful spans. And they can look like this, or like this. And okay, let's go to find that pillars in our Drupal, right? Logs, metrics, and traces. So let's start with logs. That's easy one. Let's go to reports and recent log messages, and we are here. Great. Okay, we found logs. The next challenge is to find metrics. In Drupal core, actually, we have no metrics, right? Let's look at the contrib modules. Maybe there we can find something. We have a profiler that's pretty good project. And if we install it, we can see actually some kind of metrics. So rendering time, memory usage, some other numbers. That's good, but it's not output. It's internals of the system, because we can find only them inside the Drupal panel. That's the problem. So kind of metrics we have, but they are not outputs. That's the problem. And the last one is traces. So in Drupal core, as usual, we have nothing. And in contrib modules, we can also use web profiler and xhprof. And in web profiler, we can find kind of traces. But the problem is that this module is not recommended to use in production because it slows down the Drupal a lot, so it's not the solution. And xhprof that can provide some kind of traces or metrics, I don't know, because we can see a lot of numbers there, or we can render some kind of chart that can be useful, maybe. But actually we got nothing. This can't help us resolve this problem with observability, right? Oh, yeah, we also have the simple profiler for PHP that can provide shiny and fancy and colorful charts. But actually, SPX, database log, web profiler, xhprof, and all other things are not outputs. They are kind of debugging, and especially Drupal debugging, because they display the information only inside Drupal and not can't synchronize them with other components of your system. So what have we got? We found logs, right? And no metrics, no traces, but a lot of bugs. Oh no, a lot of debug information. That's kind of sad. And now let's remember how often our Drupal works alone nowadays. So usually we have our Drupal installation, and it works with some internal services, microservices, makes remote API calls, so it's not alone. And the pretty popular case is decoupled Drupal, where we have a JavaScript frontend application that talks with Drupal using REST of GraphQL API. And again, several friends on the backend. And if you're lucky and your Drupal works alone, it still has a couple of friends, the web server and the SQL database. And we want to see what's happening not only inside Drupal, but through all the components that use it to make the site work. And actually, Drupal is a black hole from the point of view of observability, because it produces only internal information, not the outputs. And usually, the projects are not as simple as displayed here, but look like this. And Drupal is just a small component of the whole infrastructure. And we have to synchronize and integrate Drupal into all the components that we have. So it's okay to have the zoo of technologies with Golang, Python, Postgres, Overpass, and so on. And we should have some image that shows all that's happening under the hood. So observability expects outputs, not entrails. And Drupal outputs are the black hole. That's the problem. Okay, let's brace ourselves and dive into that black hole and try to find there something that we can extract. So we have actually only logs, and we can put logs into database and into syslog. And using the contrib modules, we can also put them to stdout, to files, files log, JSON log, monolog. We can put them to cloud using Grafana, Elastic, AWS, Google Cloud. And even chats. I'm not sure about is there people that use chats for logging, but maybe. And let's look at the log record. What we have there. We can find some type like content. Don't know what it means. The username, the location, and node title. And together with title, we can get surprisingly the node type and the operation type, like update. Some operations like view. And where can we find node ID? Oh, actually it's here. We can just use a regular expression magic and extract it from the URL, right? Very convenient. What about operation duration, number of SQL queries, memory usage? And we have no information, but actually we want more information from logs, right? To understand what's happening and how to fix the problem. Maybe Apache or Nginx logs can help us, but actually not. We can get the request type as a URL and the response code like 203 or 3, and that's it. So again, we have nothing. And probably that's it. That's all that Drupal can provide. And we should somehow live with it. But let's explore what's happening in other worlds. So in C++, in Python, Node.js, we have different technologies, and they maybe suffer with the same problem, right? But actually, not so bad. We have a lot of solutions for logs, like Graylog, syslog, Datadog, Logstash, Elastic, and pretty the same picture for metrics. A lot of different brands provide solutions to collect metrics, and the same image for traces. Again, a lot of different solutions that are cool and work well. So actually, we have a lot of options to choose, and it's not easy to decide what exact brand to choose for you. And now I want to ask you, what do you use to manage Drupal logs? You can scan this QR code and take part in this survey, or you can join the open the slido.com website and enter these numbers. So I pre-filled some popular solutions, and if you see that you use something, for example, Grafana or Elastic, you can just upload it, or you can put your own service that you use. And using this service, you already can start to ask questions about my presentation, and I will review them at the end of the presentation. So if you got some question, just type it and it will be saved. And I see that database log is the most popular solution. Oh, and New Relic. Yeah, so we have two leaders, New Relic and database log. Elastic, but database is a winner. Syslog. Yeah, thank you for your feedback. So actually, for Drupal, we can submit logs to syslog because it works out of the box and a pretty proper solution because storing logs in database is not very good for performance and for observability, the same problem. And that's it. Oh, yeah, you wanted to, I remembered New Relic. We have integration with New Relic that provides logs, metrics, and traces. So we can just install this module and get the web transactions time, traces, metrics, and a lot of interesting information that we can use to optimize and to analyze our issues. So that's good. The problem is solved. But your front-end team probably will use not New Relic, but something like Greylog for logs, Victoria Metrics for metrics, and Sentry for traces, because they have libraries that integrate their framework with JetBrains, not with New Relic. And your backend and DevOps team can use Papertrail for logs, Prometheus for metrics, and Jagger for traces. And again, we have a lot of brands and a lot of places where we should look the information. That's the problem. Or maybe you're lucky and you forced the front-end team to submit logs, metrics, and traces to New Relic. And the backend and DevOps team magically agreed to submit the same information to New Relic. That's pretty good. That should resolve the problem, yeah? But actually, it smells like vendor lock-in, because that day that you started submit logs, metrics, and traces to New Relic, you can just jump out and switch to another vendor. You have to continue submit the information to New Relic, and if some other vendor will provide some cool feature, you can use it because you integrated with New Relic. That's the problem. And it can be expensive, and you still have to pay a lot of money because the integration works, and you can just rework it to another vendor. So that's actually a problem, and we can find the solution maybe. And the solution is already here. The name is OpenTelemetry. So what is that OpenTelemetry? It's a collection of API, SDK, and tools to collect and display telemetry data, metrics, logs, and traces. And it's free, open source, vendor agnostic, and tool agnostic. And it already provides support for a wide variety of languages, starting from PHP, JavaScript, Python, C++, and even Rust. That's pretty good. And with OpenTelemetry, actually, the vendors are locked in, because we don't care about their libraries. We just install the OpenTelemetry library and choose the vendors that support this OpenTelemetry. And actually, a lot of vendors already declare support of OpenTelemetry, and you can see here a lot of big and small brands, and they can accept your information in the OpenTelemetry format. So it's already happening. But someone may be writing Haskell and can say that OpenTelemetry doesn't provide a library for Haskell. But for example, Jagger provides this library. And for such hard cases, we also have a solution, the OpenTelemetry collector. The collector can receive information not only in the OpenTelemetry format, but in any other popular formats like Jagger, Prometheus, and others. And then it can process data by scrubbing, normalization, batching, and sampling, and it can export them. And again, not only into OpenTelemetry format, but to Jagger and statsd. So you can have some kind of conversion from any protocol to any other protocol. And from that list of brands, we can see some solutions that can accept logs, metrics, and traces together. So it's Dynatrace, Grafana, Elastic, Datadog, New Relic, and some others. And again, we have to choose one of the vendor which is better or which is less expensive. But actually not, because we don't care about the specific vendor. Because if we start to submit data to Dynatrace, for example, we can just switch to New Relic or Grafana without a single change in your project. Just change the endpoint. Or if you want, you can just submit data to 2 or 3 endpoints at once. So the migration from one service to another is very easy. It sounds good, right? But I know that you have no time to integrate that OpenTelemetry into your website. That's the problem. But don't worry. I've integrated that OpenTelemetry into Drupal, especially for you. So here is a module web page where you can find some instructions on how to use it, but actually all what you need is to download module, check the checkbox, and press the install button, and that's it. Then go to the OpenTelemetry settings and put only the endpoint, so the host name and the port, and that's it. The rest is not needed to be configured, it just works out of the box. And then probably we should dive into clouds, into some New Relic cloud, Grafana or Elastic, but actually not. You can easily install OpenTelemetry locally, directly on your home IBM PC. So you have to just open the console and type the dev get /n/Grafana, and then just open your project, the dev site, and the port 3000 directly in your Netscape navigator. And you will see the Grafana web interface that can display you all the metrics, traces, and logs. And let me demonstrate how it works on a simple decoupled project. Oh, no, not on that project, on a pet project. Let's imagine that we are crypto investors and developed a cool project with AI and bots that raise a lot of bitcoins for us. And let's name it Bitcoin. Here is how it looks. So we have 6 magic bots that raise a lot of money for us, and 1 large gold button that makes a lot of money. And what do we have under the hood of this demo project? On the client side, we have a JavaScript front-end application on Vue.js. On the server side, we have Drupal PHP backend and a microservice on Go, because we should be modern and use microservices, right? And another microservice on Python that predict the future rates and trends using AI magic. And our 6 magic bots written in Node.js as microservices, because Node.js is quick and modern. And look, we got an elephant and a gopher, a snake. We got a zoo. Great. So here is the dependency chart. So on the client side, JavaScript front-end application talks with Drupal by the REST API. And Drupal controls our microservice on Go that makes the third-party API call to get the crypto rates. Then it controls the Python microservice that use some AI to predict how to control the bots. And then it controls the Node.js bots, tell them how to make money better. And actually that's it. So let's brace ourselves and click on the make money button. And yeah, it works. So each bot raised pretty good amount of money for us. That's great. Okay, let's compare how the making money process looks without OpenTelemetry and with OpenTelemetry. So we click it on the button and see that bots updated successfully. That's good, but what's the difference? Maybe let's start again and click on the button one more time. And oh, something went wrong. What have we do with this? Oh, probably we should call to a support engineer, right? And tell that something went wrong, please help, please resolve this problem. Support engineer will have to call to a front-end programmer because the error happened on the front-end side. And front-end programmer will look into logs and will try to find errors and find no errors. and he will call to a PHP programmer. PHP programmer will look into Drupal logs, into Nginx logs, and will find nothing, and he'll call to Go programmer, Python programmer, and Node.js programmer. And finally, Node.js programmer will find some error in the deep of different logs and fix it and report to support engineer that, okay, the problem is fixed. That is how the process usually look, right? Okay, let's compare this process if we have OpenTelemetry. With OpenTelemetry, together with the error text, we usually can see the error code, this pretty long line with numbers and characters. Its name is trace ID. And having this information, what we have to do? We have to call to our support engineer, right? And tell him that something went wrong. We see some strange numbers. Please help us. And our support engineer will call to the front-end programmer, right? Actually, no. It will look into the OpenTelemetry telescope using this trace ID and will call directly to our Node.js programmer. So how it happened? How they know that the problem is in the Node.js side? In the OpenTelemetry telescope, they see the beautiful charts that help them resolve the problem. So what we have to do, we should open the Grafana interface or any other like Elastic or New Relic. Then we should type the trace ID in the search field. And then we will see the beautiful charts. And they look like this. Oh, they are sucking us to the dark side. Let's get back to the white side. Yeah, it's better. So what can we see there? Actually, we can see our zoo in these charts. Here is JavaScript front-end application, then Drupal PHP backend, a microservice on Go, and even if it makes the call to the external API, we can see a separate line about this call, a Python microservice, and our 6 Node.js bots. And where is the problem? Actually, it is here. You can see the red icon here with that represents the problem. So the error happened on the Node.js side with the bot number 4. And if you click on this line, we can see not only the bot number, but actually the message, the exception type, and even the file name and code where the code line where it happened. And support engineer using this information will quickly understand that he should wake up the Node.js programmer and give more sleep for frontend and PHP programmer. And having this information, Node.js programmer will see the exact file and code line and can quickly fix the problem and report that all is fixed. That's awesome. Problem solved and without waking up a lot of people. Just 2 people, and that's it. So now the problem is fixed, and let's click again after the fix. And okay, we have a spinner. Let's wait a bit. Yeah, it works. Great. But it worked pretty slow, not as quick as the first time, right? And we can open the DevTools and see that actually it took 21 seconds to get the response. That's not very good. And we have no error here, so how can we analyze what's happened? Actually, we can get the trace ID of any request without any specific knowledge. So we can open the DevTools and find the trace response header. And in the trace response, we can find this trace ID. And using this trace ID, we can quickly find the request that went without error, but still we are not happy with it. And looking at this picture, we can see that the Python AI microservice took 20 seconds. That is not good. Okay, maybe it produced some logs, so we can click on it, and we have the button logs for the span. But we found no logs here. Actually, it should be hard to understand what's happening. But also we have metrics, right? Let's look maybe on the metrics. And by right-click on this line, we can choose the CPU load, memory, file system reads, writes, and other metrics that we are interested in. And let's check the CPU. Oh, on that time, CPU was on fire. So here the red line is our Python AI pod, and the green line is actually a pod of our neighbor that's mining Bitcoins while we are sleeping. Probably that's not a good idea to share your server with your neighbor that love Bitcoins. And we can just kick out the neighbor, and the problem should be resolved. So now, now we have the free server, and yeah, it works less than a second, and the bot's updated. So the problem solved. And even if all works well, we still can get the trace ID, and using this trace ID, we can be sure that all went well. And now our Python AI took 140 milliseconds instead of 20 seconds. So we can sleep well with this information. So all right, now we resolved already two problems using this OpenTelemetry, and without diving to the code, to the logs, and all other scary things. And I want to say that all this for free, with no clouds and no single code in Drupal. So you just install all locally using simple commands, and that's it. And just install the module, and no specific experience you need. But probably you want more from this. Instead of just one span, you want to see some internal operations that happen in Drupal. And for this, you have to check just another checkbox. So go to settings and enable the database statement plugin. And by enabling it, it will start submitting each database query to the OpenTelemetry endpoint. And you can even click. So here we have the request in the React application, then Drupal spans, the main span, and each query is represented as a separate line. And we can even click on the query and see the actual query text and duration and all other information that you're probably interested in. But having more than 500 spans, I think too much, right? So you're probably interested not in all SQL queries, but in specific actions that, that depends on your business logic. And these plugins can be installed and can be enabled and disabled. So it's just a regular plugin in Drupal. So you can just uncheck the database statement, and the database queries will disappear from it. And you can submit only custom spans there. So you have to enable only the request plugin and create your own spans. And here is an example of the plugin that you can write to extend this. So actually, not very scary. You extend the OpenTelemetry trace base and write your own logic that you need. And I can show you how it looks from the code point of view. So here is an example. First of all, you need to get the to create the main span with the name that you want. Then, if you have external API calls, you create the internal span, for example, CoinDesk API call. And when the call ends, you end them. Then the inner span, if you make some calculations or some other magic, you create spans for each operation. And then ends the inner span and the main span. And that's it. So not a lot of code you need, just to wrap all the operations that you're interested in several lines of code, and that's it. And after this, you will see only your custom spans here. So here we have the Drupal get operation, then the request, and then all your operations that you're interested in. Why do we have 2 lines with the request? It's to catch the Drupal kernel warming up and cooling times. So we can see that before processing the request, Drupal take several milliseconds to warm up, and maybe some hooks on initialization slows down our website. And also on the terminate event, it can be slowed down, can be slowed too. And analyzing this, you can figure out where is the problem with slow performance of your website. And together with this, you can submit any custom events and attributes here. So for example, bot can provide that he raised 63 Bitcoins for us. That's awesome. Also, OpenTelemetry provides after instrumentation. So instead of extending your code, you can write a hook where you can put the class name and the function name, and write the pre-hook and post-hook that can start span, extract some information before the function called, and when the function ends, you can again do some calculations and span, put some metadata to the span and all other information that you want. Okay, we covered traces, good. And probably you want to see metrics, that colorful charts, and we have them too. You have to install just another module, another checkbox, and that's it. And having this module enabled, you can simply get the meter with any name that you want, and create counter, and just add some numbers there, or text information, or anything that you want. And if you need to send the data not at the end of the request, but in the middle, you can call the collect information. And it will immediately send the data to the server. And if we miss this, on the terminate event, all the metrics will be automatically submitted to the OpenTelemetry endpoint. That is very convenient. So we got traces and metrics, that's cool. Oh, we forgot something, yeah? Yeah, logs. And for logs, you just need to check another checkbox. The approach of OpenTelemetry is to log not only requests that went wrong, like with exception or some errors, but every request. So if you turn on this option, it will log every request to logger, even if no errors or warnings happened on it. And let's dive in again in our logs. Usually people submit logs to syslog, and without OpenTelemetry, they look like the line like this. And we can use some regular expression magic and split this line to the key value representation. And with OpenTelemetry, actually it looks kind of the same. Yeah, what we have? Oh, we have trace ID here, and here. So using this information, you can get the problematic request, and using the trace ID, you can quickly find metrics and traces of this request using the Grafana interface or any other vendor interface. And also, I implemented a separate module, OpenTelemetry logs, that can submit logs directly to the OpenTelemetry endpoint. So you don't need to submit logs to your database, to syslog, or to file. They go directly to the OpenTelemetry endpoint, and you will have all the information at one endpoint. That's very convenient. And with this, logs will look not like one text line, but like this, key value storage with all the fields available separately. And you can quickly filter, for example, by the channel or severity or user ID and so on. You can find the request URI and message here and trace ID. But probably this is not enough because having only message is not very clear, and we need to put some more information to logs, right? And for this, I have another solution to extend the Drupal logs. The name is extended logger. With extended logger, we can convert the logs like this to the JSON format and include there much more useful information that you probably want to see. So instead of the request URI, you can put the category, the entity type as a separate field, entity bundle, not as a part of the message, entity ID as a separate numeric field, and even metadata. For example, if you want to track what exactly changed in the node, you can put the title, body, and field category div in the metadata, and you will have it as a separate field in the logs directly without any traces and metrics and other stuff. That's very convenient. And the link to view, actually, if you submit the logs to syslog, it will be not a link, just the view word. And here we have the source of this line, so we can detect not only the view word, but also the URL, node and node ID. That is very useful. And instead of the message contain article updated and the node title, we can see the raw message. So the type updated and the title. And you can extract specifically the type of the node or the title that you want as a separate field in the logs. And together with the user ID is okay, but probably you have a lot of users. And here you can put the username and the user group, for example, customer, to filter out all requests made by a specific customer, for example. And having this information as a separate field, you can quickly filter out logs that you're not interested in and analyze only logs that you want. But since this is a good topic for the next DrupalCon, because in the extended logger module, I have a lot of interesting things to show you. And now let's concentrate on observability and OpenTelemetry. So what have we found with the OpenTelemetry module in our Drupal? We found logs, and now we have full-featured metrics and traces. That's very good. And actually, OpenTelemetry is not only for web services and applications. A lot of databases already introduced integration with OpenTelemetry, and you can see all the metrics and traces of specific SQL queries if you want, or if you use NoSQL database, the same. Also, for containers, Kubernetes, Docker build kit, containerd. For services and tools, Nginx, Apache, Jenkins, Kong, they also integrated with OpenTelemetry. It works also for mobile applications, virtual and even bare metal servers. And soon it will be for all the other things, and we can live happy life with this. And here is the roadmap. So you can scan QR code again and put some new ideas that you want to be implemented in the module. So first of all, I want to fix all the bugs and implement all your feature requests. The second is sampling rate configuration. By default, it submits 100% of the spans, but if you have the heavy loaded website, you probably want to submit only 1% or 5% of the requests, and it will show you the picture without overloading your server. Also, I want to implement the HTTP client plugin and after instrumentation support. Probably I will do this in a couple of years. It looks great, but maybe it's not good for performance. But actually not. All telemetry data is sent upon the kernel terminate event, so after the response is sent to the user. So it doesn't slow down the response time. But let's try to measure it anyway, with the help of a usage meter module that can give more information about what's happening on the server side. So I ran the Grafana Cas6 load testing and found that actually it adds only 2 milliseconds average difference on P95 That's pretty good. Yeah, on the start we have some slowdown with 20 milliseconds. It's because of caching, because of some warming up. But then we can sometimes even minus 9 milliseconds. So the website works quicker with OpenTelemetry than without it. So it's actually not a problem with performance. And you can even speed up with this using the local collector. So instead of submit data to the remote endpoint, you can run the OpenTelemetry collector locally. It will collect all the data and then upload it to the remote server that can be slow. And use gRPC protocol that also optimize the performance. And about reliability, so everything is covered by unit tests and even Nightwatch tests. So if you submit some feature request or patch, it automatically checks that all works and nothing is broken. Not all, but almost all is checked. And this is done with the help of my another module, test helpers. And you can see on the Drupal website that for each merge request, it will run the Nightwatch functional test and unit test using PHP unit. So Drupal with OpenTelemetry became a full member of the observability club, and we can integrate it into serious projects, not like pet projects like I displayed, but any project for any large businesses. And the module made with the support of EPAM company, where we have different projects with heavy load, and without OpenTelemetry we suffered a lot. And implementing this feature simplified our task, and if you suffer with the same problems, you can ask me or EPAM for the support, and we can resolve your problems. So that's all that I wanted to show you. Here you can see my contacts, and you can even download the presentation also for free using this QR code. And also want to mention that you can join the development and help with implementing new features, or at least test this module on your websites. And on Wednesday, we will have here a contribution day. So you can invest your time and test my modules. So at least install this OpenTelemetry module on your website and play with it and report any issues that you got. And here you can find links to some issues that I want to work on. And if you are ready to join, please find me, and we will try to resolve them together. And here you can submit some questions or ask them loud. Thank you.
We got a few minutes.
Thank you. Thank you for the wonderful session. It's very inspiring to know about what OpenTelemetry does. I have a couple of questions. One is around the data side. If you are setting up OpenTelemetry on a server, then I come from AWS background. So would you set it up on an EBS volume or an EFS volume? Would you have log rotation for all the data that you get?
Yeah, usually any solution. So I showed the Grafana interface, but you free to choose any other solution that have log rotation. You can even put the data to the S3 endpoint and remove the old data that you want.
Right, mount S3. Okay, and the other question was around load balancer. You said that in the configuration there's an endpoint. Is it like a single server that you want to point to, or would you want to back it up with some load balancer? Because what happens if that server
Yeah, it's a single endpoint, but here you can put any load balancer, because logs, metrics, and traces uploaded asynchronously. So some logs can be submitted later than, for example, old log record can be submitted before the new log record, and it will be not a problem because it will put it in the right place.
Right.
So it's asynchronous logic, and
okay, thank you.
works well.
One last question, and is there a queue management that we would want to do with every log? Like I'm sending multiple logs to this OpenTelemetry, so would that part be of SQS, send it to a queue, and send them?
Actually, OpenTelemetry collector do this stuff, so you
already
can
does that.
install it locally, and it collects. And even with one request, if you have 5 spans, for example,
It'll get
it make the batch and then submits on the end of the request them as a one request. And the local OpenTelemetry collector will collect all of them cache, and if you real endpoint went down, it will store them on the memory and then retry. So you will not lose any information.
Thank you so much. Thank you.
Alexei, I just want to know one thing. Where can we download the money-making bots?
Oh, it's a secret. But you can ask me later on the after party. Maybe I'll share the link. More questions? Yeah. Thank you. Thank you for your attention. I hope this module will help you with your pains.